Hello everyone and welcome to another video in our section Quick Facts about Controlled Environment Agriculture. Today we're going to speak about a topic that we know is very useful for a lot of growers. We're going to speak about nutrient uptake and how can we fix sometime nutrient deficiencies. When managing nutrition in hydroponic systems, it's important to know that if we provide all the ingredients of our formula to our plants, sometimes there are environmental variables that can affect the nutrient uptake. In this case, this means that sometimes we can have, for example, a nutrient deficiency that is caused but something else that the amount of salts on your nutrient solution. Sometimes there are physical and chemical variables that can affect nutrient uptake. It is important to understand how plants take up nutrients in order to fix sometimes nutrient deficiencies. Even though that you have provide all the nutrients to your plants, sometimes there are variables that you need to control on your hydroponic system to avoid nutrient deficiencies. We can group them in a physical and also chemical variables. So let's start with the chemical variables. So which are the chemical variables affecting nutrient uptake? pH is one of the most important variables to manage in hydroponic systems. I think we all know this. However, it's important to know a little bit more about plant physiology. It's important to understand how you should expect the system to behave, obviously based on information on how the plant is taking up nutrients. When you have a closed system where the water is recirculated, you should expect the plant to take up some nutrients faster than another ones. If some nutrients are taking up faster than another ones, that means that some nutrients will get accumulated in the nutrient solution. That can affect pH. And also in hydroponic solution, we usually use a source of nitrogen, nitrate. Nitrate is a compound that tend to increase the pH on the root zone. So it's very important to monitor a closed system because you should expect to see an increase over time on your pH. You need to monitor this and fix it. However, if you don't do this, you will start to see some nutrient deficiencies. When pH is out of range, and most of the time when it's higher than 7, for example, you will start to see some nutrient deficiencies. One of the most common symptoms are iron deficiency, which is the one from the picture. So let's just start from scratch, learning how the plant is taking up nutrients and how this can affect our pH. Most nutrient solution has nitrate as the source of ammonium, or nitrate is in the higher amount. So you should expect to see an increase over time on the root zone. This is a slow increase. If you have an increase from one day to another one, that could be the water source, and that's important to check too. So obviously, you can also find different behaviors. You can also see, for example, a behavior where the pH is going down. So if you see this, this could be, in some cases, there are nutrient solutions that are based on ammonium. This is not very common, but it could be. So if you have a fertilizer that is based on ammonium, ammonium, on the contrary to nitrate, will tend to reduce the pH. So either way, you need to check the pH and maintain the pH within the range. If the pH is outside the range, you can see nutrient deficiencies. Let's start defining the general categorization of hydroponic systems. We can work with closed systems where the water is recirculated, and we can also work with open systems where we have a drip and also a drainage. These systems are usually substrate based systems with drip irrigation, and both systems can sometimes have a tendency to have some variables that can be affecting the uptake or passive nutrients. So now let's speak about the physical variables that can affect nutrient uptake. There are some passive nutrients like calcium, for example, that can be affected by physical variables. So airflow is very important in greenhouses and plant factories. Here it's common to find calcium deficiency when you don't have good airflow. So when we don't have good ventilation, you will have an increase on the boundary layer, which is this bubble of heavy air that sits on the surface of the leaf and make the stomachs a little bit difficult to work. So, stomachs are in charge of moving water and moving also nutrients, passive nutrients, the ones that move within the water. So, if you don't have a good ventilation, you can expect to see calcium deficiency. So always pay attention to your greenhouse and also your plant factory system to have good ventilation, good density also is important in order to avoid calcium deficiency. So now let's move to another variable, which is light intensity. So light intensity is a variable that can affect the movement of passive nutrients in a specific systems. So we know greenhouses and plant factories are not the same, right? So in plant factories, based on all the physical properties that we have inside of these systems, we can see problems of calcium deficiency that are linked to light intensity. We don't see this in greenhouses because the greenhouse has a different volume, different movement of air and the air density there. So, in specifically plant factories, we can see a problem of calcium deficiency that is not only linked to airflow, it can also be linked to light intensity. If we exceed the DLI of 17 for more than 3 days, we know based on research that you can start to see sometimes tip burn, which is the calcium deficiency on leafy greens. And for this, in order to avoid this, we should try to maintain a photo period and a light intensity that will help you to provide the light that the plants requires. So we recommend to have a light intensity that goes from 250 to maximum 300 ppf. So this is micromoles per square meter per second. If you have something that is higher than that, you need to work a lot with your photo period in order to avoid calcium deficiency. Remember, this is something that is linked to plant factories. Usually, if you speed up the crop inside a plant factory where the ventilation and all this pressure of the air is a little bit different, you can trigger this problem. So now we're going to speak about moisture and salts. Both are related, that's why they are on the same slide. So, moisture is the amount of humidity that we have on the substrate. And we already learned a little bit about how the stomachs behave, right? If we don't have good ventilation, the stomachs will have like a hard time trying to do gas exchange. So, if we don't have a good amount of moisture on the root zone, the plant will try to save water. For this, the stomach will close. So if the stomach closes, then the water movement will be reduced, and also the uptake of some passive nutrients like calcium, will be reduced. So as a consequence, we will have calcium deficiency in some crops. Like for example, tomato could be an example. In other situations, sometimes we can have an increase of salts. So, when we have an increase of salts on the substrate, for example, coconut coir is a substrate with a tendency to accumulate salts. So, it's very important if you are working in an open system, you have a drip and you have a drainage. It's always important to check the drainage to know if the system is accumulating salts, which is something that can happen over time. And you need also to check this at the beginning to get like sure that the substrate is clean. So if you have an excess of salts on the substrate, then the plant will do the same response as drought. So that's why these both are on the same slide. If you have an excess of salt, you will have the same response as drought stress, which is the one that we already explained. So the stomachs will close and you will have the same problem. So it is important to check the amount of irrigation that we provide, which I think is something that we already know and we can manage it. But in the aspect of the salt, sometimes we forgot about this, so it's important to check drip and drainage because the salts can get accumulated over time on the substrate. If that happens, you can wash the substrate with water. So now let's speak about another variable, physical variable that is important to manage in greenhouses and plant factories. So relative humidity. Guess what? Relative humidity is also linked to the stomata behavior. We know that if we have very low humidity or very high humidity, that will affect the transpiration on the plant, which is regulated by the stomates. So when we have a lot of transpiration or very limited transpiration, that can affect nutrient uptake. So let's explain this with two different crops, two different examples, starting with the strawberries. The strawberries, they love humidity. We know that nighttime humidity is important for this crop. You should target to have 75% nighttime humidity for strawberries. If you have something less than this, you can expect to have some tip burn or calcium deficiency. How can you spot the symptoms? You will see some necrosis on the leaves, just like this picture, and you can also have necrosis on the calyx. So we know nobody wants to buy a strawberry with a dead calyx, right? So it is important to have a good management on your greenhouse to try to maintain the humidity with at least 75% humidity at night. Other situation is in the case of tomatoes. So tomatoes, if we have like very high humidity or very low humidity, that can also affect the transpiration of this crop. A situation that is very common is when we have these symptoms, which are blossom and rot, that we call blossom and rot. So blossom and rot is calcium deficiency. And there are different situations that can trigger this problem, but the most common situation is when the plant is transpiring a lot. When the plant is transpiring a lot, you will see this problem of necrosis at the bottom of the fruit. You won't see the problem on the leaf. The leaf will be it would be healthy, and this is because when you have a lot of transpiration, you have a lot of movement of water. But the movement of water is so fast that the movement to the fruit is restricted. So then you will have fruits with a problem of calcium. In order to fix this problem, most of the time need to reduce the humidity around the plant by keeping good airflow, by having the plants prune so you can have more airflow, to use the exhaust fans or vents. So remember, either way, high or very low humidity can trigger this problem in tomato. And for strawberries, we should try to maintain a good nighttime humidity. You can check that the plant is behaving okay. In the case of the strawberries, if you come at the morning in the greenhouse, you should see like guttation, or if you see the symptom, that will mean that the plant is taking up the water, is taking up nutrient, everything is fine. In the case of tomatoes, tomatoes are plants that are very tall, and they do a lot of shade, they transpire a lot, so we can create easily situations that will harm our plants with a bad management of the greenhouse. So pay attention to try to avoid any nutrient deficiency that can be linked to the management of the greenhouse. So now you know a little bit more about nutrient uptake. Remember, even though that you are providing all the nutrients to your plants, sometimes you can see problems, and that doesn't mean specifically that you need to add those nutrients to your plants. Sometimes there are things surrounding the plants on the environment, on the root zone, or in the air that can be the cause of the problem. So if you have any problem, now you know the steps to follow in order to fix a nutrient deficiency. If you want to learn more, please subscribe. Remember, my name is Carla Garcia, Horta America's Technical Service. See you on the next video.